Hey guys, I just wanted to join you here and kind of show you a little bit with your homework sheets that there are some terrific notes for you to include as far as orbital diagrams go. And you'll notice when we did the video, they had circles. I said you could also use lines, which is what I use when I show you an example. I'll show you that. Now you'll notice a third option, you can have boxes. And so it says an orbital diagram uses boxes, and remember you can use lines or you can use circles. And you're going to have arrows that are going to represent the electrons in an atom. And so each box in an orbital diagram represents an orbital. Orbitals have a capacity, but it's very nice. They remind you that an S sublevel has one orbital, a P sublevel has 3 orbitals because you can fit up to 6 electrons. A D sublevel has 5 orbitals, you can fit up to 10 electrons, and an F sublevel has 7 orbitals, you can fit up to 14 electrons. And in writing an orbital diagram, the first step is to determine the number of electrons. I believe it's super helpful to also do an electron configuration for that element. It reminds you of the Aufbau rule, the Pauli exclusion principle, and Hund's rule. So in 1 through 6, you are going to look at that orbital diagram and determine what element it is. So I'm going to let you guys try that, but I just want to show you an example of writing an orbital diagram. I'm going to pick carbon. The reason I pick carbon is I don't have to put I don't need to do a noble gas thing or anything. I believe to do an orbital diagram, it's one of the best steps to first do is write the electron configuration. So carbon is a 1s2, a 2s2, a 2p2. So when I do the orbital diagram for carbon, I use lines. So this is my 1s, this is my 2s, and remember my 2p, it actually has 3 orbitals. So the 1s is full, so I'm going to do an up arrow and a down arrow. The 2s is full, so I'm going to do an up arrow and a down arrow. The 2p only has 2 electrons, and you'll remember that I must fill unoccupied orbitals before going back and pairing them up. If you're doing a test or a quiz, I will look for this third orbital in a P sublevel, just so that you know it's there, okay? If you have any questions about this, please do not hesitate to ask me. The second part, and this is some information I want you to add to your notes, is about Lewis dot diagram. And Lewis dot diagrams involve the valence electrons. Now, when you were in class or watched on the video, you can determine the valence electrons from the electron configuration. It's going to remind you, when the electron configuration is known, the number of valence electrons can be determined by adding up the electrons found in the highest energy s and p orbitals. An example of Lewis dots, this is one for selenium, all right? So selenium has 6 valence electrons, because if you look at the electron configuration for selenium, it has 4s2 and then 4p4, so it has 6 valence electrons. To do the Lewis dot, you'll notice we do this symbol, and then we place up to 8 dots, if it were to have 8 valence electrons, around the symbol. Generally, it's done in an orderly fashion. There's usually 2, and then 2, and then 2, and then 2. I'll do some examples of some things down there. It just talks about a system of tracking valence electrons was developed by G.N. Lewis, which is why it's called the Lewis dot diagram. So in this system, the element symbol is written to represent an atom, and dots are written around the symbol to represent the valence electrons. These dots are generally spaced out evenly. Since the largest number of valence electrons from the representative elements, those are the S and P block elements, so that's a good thing to highlight, is 8, we place a maximum of two dots on each side. So you can answer these questions on your own, but you're going to write Lewis dot structures for the following, okay? And I kind of like that you're given some electron configurations. So what I'm going to do, for example, is 25, okay? I have to get my periodic table. And so now that I have my periodic table, I can look at this, and I'm going to look for the valence electrons first. So I see 6 S2 electrons, and I see 6 P5 electrons. So this has 7, ooh, that doesn't look like a very good 7 valence electrons. And 6 P5, I'm going to go to row 6, 1, 2, 3, 4, 5, 6, over to P5, and this should be astatine. You should see that this is astatine. So I'm going to do the symbol for astatine, which is AT, and then I'm going to do 7 valence electrons. I'll do 1 on each part, so that's 4, and then I'll go back and pair some up, 5, 6, 7. All right, so that is my Lewis dot for astatine. Let's do this one, okay? This is 4s1, so this has 1 valence electron, and 4s1 is potassium. So my Lewis dot for potassium is a K with a dot. And I usually start over on the right-hand side, but you can put your dot anywhere. You can put it here, you can put it on the top, you can put it on the left-hand side, or you can put it on the bottom. So that tells you about Lewis dot structures. You have these problems, but they're very pretty straightforward, okay? You will do write the electron configurations first, or look at where they are on the periodic table and determine how many valence electrons they have from there. So your homework then is to complete the orbital diagrams, the Lewis dot structures, the Lewis dot diagrams, and the bottom part of page 4. So you may duplicate some information here. So do, if I were you guys, I would do the Lewis dot diagram paper first, and then looking at the ones that you did, the 20 that you did down here, there is some duplication with the problems that you have to do for the bottom part of page 4. So I will check for completion at the beginning of class for these when you come back on Monday and Tuesday after break. So if you do have questions, don't hesitate to ask, or you can